Hey everyone, and welcome back to this class, Advanced Convolutional Neural Networks. In this final lecture on building ResNet, we are going to build on what we did in the last lecture and finish up the rest of the layers. The only thing we need to watch out for is that TensorFlow's implementation of softmax is different from the Keras version of softmax, so they both output slightly different answers. What's actually super weird is that even if you try to do a little hack where you replace softmax in our model with the Keras version of softmax, this still results in a slightly different answer. If you want to see some tests I did to compare different implementations of softmax, check out the file testsoftmax.py. Note that the common implementation of softmax is to subtract the max over all the elements first. This is because we know that exponentiating something will give us a very large number, so we don't want any of the inputs into softmax to be too large. Otherwise, we get something called numerical overflow. You can prove pretty easily that adding a constant to an array doesn't change its softmax, so I'll leave that for you as an exercise. The actual solution I ended up using was to remove softmax from both models completely. This requires a little bit of surgery in Keras, but nothing you haven't seen already. It also fits with the way TensorFlow is used, because as you know, TensorFlow computes the cost over the logits, rather than applying the softmax directly. So essentially, this script is the same as the previous script, except longer and with more of the same stuff. I suspect you know by now that if you want to look up the shapes of each element, you can print out the Keras model in the console or use the summary function. So basically, it's all the layers we had before, but now with the additional ResNet blocks and then the final dense layer. Remember that the layers are dependent on which version of Keras you're using. For these experiments, I was using version 2.1. The first thing we do here is define the additional layers we need for this script. That's average, pool, and flatten. We just want these to have the same interface as all the other layers. Next, we have our custom softmax function, which we discussed earlier. We are actually not using this, but it was used in the comments. Next, we have our final dense layer. Note the lack of activation function. We also have the copy from Keras and getParams functions as usual. So the architecture, which I'm sure you're familiar with by now, is convolution, batch norm, ReLU, and maxpool. And then for the conv block identity block pairs, we have 2, 3, 5, and 2, where that's the number of identity blocks following single conv blocks. And at the end we have average, pool, flatten, and dense. The copy from Keras function is particularly annoying because you have to track down each layer from the Keras model. It is a good exercise, however. And then as usual, we have forward, predict, set session, and getParams. So the main section is mostly the same, as it was for getting the first few layers, except now we're going up to the end of ResNet. There's just a bit of extra code here where we get the second last output of ResNet, pass this through a new dense layer, and then copy the weights from the old ResNet's final layer. So let's look at the results.